Hello, everyone, and welcome to SPE Live. I'm your host, David Gibson, for today's broadcast. Thank you so much for joining us for today's SPE Live Tech Talk here with Schlumberger. We'll be discussing automating the process from well plan to drilling today. And as always, this is a live broadcast. So the whole point of this is for us to be able to interact with you, the audience. So let us know where you're watching from. As we're going along, let us know what your questions are. We've got an expert here to be able to answer your specific questions. You get to be able to ask them directly, or I'll ask them, whatever, but we'll get your questions involved in today's show. So let us know what your thoughts are. Let us know where you're watching from. And most importantly, let's have fun. All right. So today, we are talking about downhole automation of an RSS and at-bit steering system, downhole automation of an RSS and at-bit steering system has been a continual evolvement the past 2 decades, from drilling vertical to along a constant inclination, and more recently, autonomously along a constant inclination and azimuth. During this broadcast, we'll take a look at the next step forward in this space, autonomous directional drilling, which from what I hear includes autonomous steering and through any section of the wellbore. Joining me for this tech talk is Gilles Vie from Schlumberger, where he is the product champion for RSS and at-bit steering system tools. Welcome to the SPE Tech Talk, and thank you for joining us.
Hello, good morning, David. Hello, everybody.
It's great to have you on camera with me here once again. So first off, guys, audience, let us see what you have to say. Send us your questions in the comments, and we're also interested to hear what your reactions are during the conversation. So we encourage you to engage in the conversation. I know I already said it once, but we're just reminding you, come on, we want to hear your thoughts. All right, Gilles, if you could start us off briefly by talking about the ambition behind automating directional drilling.
Well, yes, David, what we're going to talk about today, as you introduced, is really that this quest that exists in our industry to automate the process, to go exactly like you said, to go from a drill plan to actually drilling a hole. And our vision in Schlumberger is an ambitious one, but it's been a clear one. And it's been
Gilles, hold on just a second.
Yes.
I think we've lost your camera.
Oh.
I'm not 100% sure. I'm waiting to, are you able to, I see. Okay, I'm sorry. Maybe it's just coming across on my end that I didn't see it. Oh, wait, there. Now we see you, but it's fuzzy. I apologize. Go back to where you were. I just wanted to make sure because I know that this is a very important moment for you guys. So,
all right.
Go ahead. Sorry.
No. So I was talking about our vision in Schlumberger when it comes to automate from drill plan to drilling deviated well. And this ambition that we're going to talk about, this vision is really an ambitious one, but it's been clear and it's been unchanged for the past 18 years, like we're going to be talking about. And really our ambition is to provide to the industry a self-steering BHA downhole. So if you could maybe pull this image I sent you with, here you go. So exactly this one, right? So to clarify this vision, right, of a self-steering BHA, 1 year ago, we introduced this autonomous directional drilling vision, which is really everything we're going to be talking about. And as you can see, we clarified at that time last year 6 levels of automation. This is to clarify a little bit about where we stand, for our customers to precisely know what we talk about when we talk about automation. And furthermore, we grouped our efforts in these 4 pillars that you see on the right side. So it goes from intelligent planning. We can also, everything we need to plan properly if we want to automate the whole process, to intelligent execution. We need to click things together at the surface, then downhole automation, and finally surface automation. What I'm going to talk about mainly today myself, my domain, is this one pillar called downhole automation. And that's really what I want to develop discussion with you today, David.
Awesome. I can't wait for this. Okay, so let's discuss a key problem everyone is trying to overcome in one way or another, and a measurement of universally tracked, analyzed, debated, and that is time. So let's say we are working on a project without any downhole automation and surface decisions need to be made, getting data both up and then back downhole that can take minutes. How are you guys solving this? Or how are you guys tackling this problem?
Yeah, so I mean, first of all, you described the problem very well, but maybe let me come back to the definition of the situation today just a little bit, so that once I talk about what we're doing about it, it's going to be clearer. But you actually define it pretty well, right? One of the challenge we face in the way we are controlling our RSS or ABSS tools today is when we do it from the surface. It can be actually a manual controlled surface or an automated controlled surface, but in all these scenarios, the loop time when we control from surface is actually a long loop time. And you mentioned it, right? So the first thing you need is to get a feedback from what's happening downhole. What's the course currently taken by our tools downhole? And this feedback from downhole to the surface is going up via mud pulse or via EMAG or other ways, but we're talking about minutes to go from downhole to the surface and being available to take a decision at the surface. Once the decision is taken at the surface, then you need to send a corrective action to the tools downhole, and you do that via downlinks. Again, downlinks can be sent via flow fluctuations, they can be sent via EMAG or other ways, but this is also talking about minutes. So this whole loop, right, from seeing what's going on, taking a decision at the surface, correcting it, and the tool downhole applying corrections is 10 to 20 minutes. And that's very, very long. And that creates some issues for our customers, right? So the first one is you have to intervene a lot. There is a lot of downlinks being sent from surface to downhole, and this is adverse to the efficiency. Second, our directional drillers and our drillers at the surface in this process are extremely focused on getting the trajectory on plan and a bit less on drilling efficiency. So we're losing a little bit in drilling speed here very often. And the final one is tortuosity. Because you correct, so there is such a long time between corrections, the tool can actually evolve with the wrong settings for a while, and it's getting really far away from trajectory in these long loop times, right? And I can create some adverse tortuosity downhole. So I can from there, I can talk a little bit about how we actually fixing it, right? And if you could pull maybe the picture number 2 that I had sent you, here you go. Thank you very much. So you can see here on this picture, right? In yellow, you have the loop time that goes to the surface and back downhole. And really what we've really strived for in Schlumberger for the past 18 years is to try as much as possible to have the decision, actually not make any decision, but have the tool change its steering on its own downhole based on the measurement is making in the second, and not go through the surface. Have the tool do by itself what it needs to do to stay on a given direction. And that's really downhole automation. So we started doing this in 2003 with our auto vertical and auto inclination mode. At that time, very early times, right, we could follow an inclination. So 0 degree for vertical, 10 degrees for an inclination, etc. Right? This was the easiest first step. Much more difficult. In 2008, we added the capability to follow an azimuth. So that's technology-wise, this is really a step change, a challenge, right? So we've been doing that since 2008 in Schlumberger. And why is it a challenge? Because these magnetometers and the shock and vibrations and the drilling conditions close to the bit, it's very hard to get a clean measurement from them, from which you can take a decision to adjust your steering. But we've been able to do that in Schlumberger since 2013. And the very last component we are bringing now to the equation is to be able to self-control our tools downhole along a curve. And I'm going to come back to that a little bit. So why it's better, right? Why it's better to control downhole as opposed to control at the surface as much as possible is you're going to get much fewer downlinks sent from surface to downhole, so much less interference on the drilling process. The tool is going to do its stuff downhole. Now that the tool is adjusting itself downhole, your directional driller and your driller at the surface, they are much more focused on drilling performance, and that's going to show on the rate of penetration. And finally, you get smoother trajectories. So you're going to get a lot more smaller adjustment downhole as opposed to lot less frequent but more violent change of directions from the surface. And that's going to get you much closer from the intended trajectory, which much less micro tortuosity. And then I touched on it a little bit, right? But why it's so hard? I mean, it would be easier, right, to do it from the surface. But why do we strive in Schlumberger to get to know why? It's really the first thing you need to do is you need to have your sensors close to the bit, right? So both the inclinometers for the inclination and the magnetometers for the azimuth, and you need to get them close to the bit because the further away they are from the bit, the longer will be the reaction time, even downhole, right? So you need to see quick, in time, and in depth the deviation of the BHA from the line. That's a technology challenge, but that's something you have to be able to do. The second thing is you have to have good measurements dynamically while drilling under shock and vibrations, drilling north-south in a zone of exclusions. And for this as well, you need to have some advanced, good quality measurements downhole. And you need to have fast controls, right? So in Schlumberger, we measure hundreds of times per second. We average this out, and then we take decisions downhole every second on adjusting using our tools following these logics. In a nutshell, that's what it is.
So it's not only, so then get this right, not only are y'all speeding up that process, but you guys are also seeing other advantageous benefits from replacing this long surface loop.
Correct. So the advantages are threefold. So number one, right, when you downlink from the surface to downhole to send a corrective adjustment order to your auto-receivable system or at-bit steerable systems, usually you do it, so you can do it via flow fluctuations, via EMAG, or other ways, right? But you do it usually, you can do it while drilling on bottom, unchanging the drilling parameters, but often you still do it on bottom while drilling, but you are slacking off a bit on the drilling parameters to enable for the signal to be received properly downhole. And sometimes in extreme conditions, you even do it off bottom. So reducing the downlinks from surface to downhole is going to improve the efficiency of drilling these sections. The less you're going to have, the more fluent is going to be the delivery. The second advantage is on drilling speed. And this we've seen, and I'm going to show you some examples at the end. Really, we drill faster. Once your directional driller is feeling safe about the trajectory, is just in a control mode as opposed to really being on the top of it every second, then he's really looking at drilling performance. So now the tool is doing the curve or is doing the tangent on its own or the lateral. I'm going to push the parameters to a maximum, and I'm going to see if the tool follows up downhole. And that really yields some faster on-bottom rate of penetration. And the last advantage is micro-tortuosity. I mean, if you have all these little, very frequent downhole adjustments made automatically by the tool, then you are creating much less tortuosity than if you are making some violent but infrequent changes every 20 minutes or 10 minutes in a surface control.
Well, you mentioned that this has been an 18-year journey, or at least it was there in the video. I hope you can share a case study or two about the latest development.
Yes. So what we, like I said, right, so 18 years ago, what we introduced was the capability of the tool to drill vertically without any control from the surface. We call this auto vertical. And that's a very successful commercial offering we've had for 18 years now, right? So you just program your tool at the surface, put it in a hole, and it's going to keep vertical, 0.1 degree, efficient. And you don't have to think of it. Just push on it, it's going to stay vertical. That was a great first step. And we have, I mean, hundreds of runs in these configurations. Now, the second thing we did, 2013, was auto tangent, right? So being able to follow a straight line in inclination and azimuth by itself downhole. And that's really what enabled us in the US, for instance, right, in the very long laterals in unconventional wells. For 8 years, we've been using that feature. It's really what gave us an edge at being efficient and fast in these laterals, because we can push on it as hard as we can at the surface, and the tool will automatically, every second, auto-adjust itself to stay on the line despite whatever push we put on it. Now, today, the very latest feature we are introducing to the industry is auto curve, and that was yet another barrier to break. So we are able today to actually send a command to the tool, and what the command we send is say, okay, I want you to build a curve as per this tool face and as per this dogleg. And the tool downhole, without touching it, is going to do it by itself downhole. So the barrier we broke in 2013 for auto tangent was being able to measure a good azimuth continuously. The barrier we break now by doing auto curve is to be able to adjust our target inclination and azimuth as the tool goes downhole, right? So basically we have a way of measuring, of feeling the rate of penetration downhole, and the tool will adjust its target to continuously nudge to build a curve. And we've done this for a year now. So you're asking, for example, David, right? So we've been doing this auto curve for a year now. We've been doing it in many different places around the world. We've been doing it mainly in the US. So we have a lot of cases of succeeding doing that in the US, in the unconventional well. So in the very acute curve before the laterals. We've also been doing it offshore in the North Sea, and we've been doing it also extensively in the Middle East. And we have several examples. So actually just last week, right, we published 5 case studies on our public website. You can go and consult them from these 5 regions, and where we coupled the auto curve capabilities with several of our rotary steerable systems or at bit steerable systems, and we got great achievements. I can mention one, maybe one from the Permian. It's a generic case where for a customer, we actually drilled 7 curves on a pad, right? We did 7 wells, 7 curves. And on these 7 curves, when we average things out at the end, we compare them to, exactly the same pad next door when we were not using AutoCurve. So we measured against ourselves using AutoCurve that we had reduced the number of downlinks by 55%, right? More than half the number of downlinks. And we also had increased the downhole ROP on these wells by about 39%. So that's the level of efficiency we bring in the curves when we use AutoCurve for our customers. AutoCurve is the very latest addition to this downhole automation that we call autonomous downhole control systems in Schlumberger.
Gilles, that is absolutely amazing. And I have to ask this question before we go forward. How hard was it for you to keep that a secret while you guys were having this much success over the last year and recently over these last couple of wells?
Don't know. We actually partnered. So one thing that helped a lot in taking the risk in doing this field test, and it was not a big risk because we can disengage in a downlink, right? So we can go back to manual immediately. But the thing that helped is we have a certain number of customers with whom we partner very closely on this vision, right, of a self-steering BHA. We have some of our key customers who are, very, very keenly interested in partnering. They have the same vision we have, right? So it was very easy for us to go on their wells and to get into their story as well, right? We are really, our story and their story is really matching very well in delivering these autonomous downhole control systems. And I guess it stays between us, but other than that, I wouldn't be able to say. So we just come out publicly now. I guess we're going to talk about it more from now, and we are ready to do so.
Excellent. So we've got some questions and stuff that are starting to come in from the comment section. We'll let those continue to come in. So if you guys that are out there watching right now, if you've got any questions or comments, please feel free to put them in the comment section. We'll get to them in just a second. Let them kind of like fill up so that we're not just getting too choppy with them. So I do have a question here for you, Gilles. How does autonomous directional drilling differ from other automation offerings?
So maybe one of the things we focused, right, in Schlumberger, if you remember the 4 pillars we looked at the very beginning, right? So we are investing in developing solutions and features in every single of these 4 pillars. So we have a holistic approach to go to that vision of a self-steering BHA, right? So what I'm taking care of personally is downhole automation. It's just a part of the whole autonomous directional drilling. So maybe what makes autonomous directional drilling different is the fact that we are attacking in every single angle that needs to be attacked to get to the complete solution. Other groups in Schlumberger are working on surface automations. Other tools are working in intelligent planning, and other groups are working into intelligent executions. And once you get all the pieces of the puzzles together very, very soon, then you're going to get, I believe, one of the best offer in the industry.
Oh, all right. So once again, guys, everybody that is out there watching, please bring in your questions. We'd love to be able to have Gilles be able to answer those for you, because we know that you guys aren't asking me any questions because I have no idea what we're doing here. No, why is it so important to bring automation downhole into the tools?
Well, it's this surface loop time, right? We've been talking about. It's about efficiency, and we believe there is no other way, right? If you want to have the fastest reaction to be as loyal as possible to the original intended plan and to do this as transparently through the drilling process, you have to do it downhole. You measure downhole hundreds of times per second, your inclination and your azimuth. The tool has a capability to change its control systems every second. But if you don't take opportunity of that, right, if you cannot take, you're going to have to go to the surface and it's going to take 20 minutes instead of 1 second. And that's a huge loss of efficiency, right, in terms of drilling speeds, in terms of efficiency, in terms of tortuosity. So that's why, right, it's so important to try to get as much as possible of the intelligence downhole, because that's where the measurement is made and that's where the corrections is going to happen. So if you can make it happen right there downhole, then you get the maximum efficiency. It's not easy. 18 years we've been working on it and we have not finished working on it. It's not easy, but there is no other way if you want to make a difference, I believe.
All right, so we did get a question in here from Charles, and he's asking about how do you incorporate geosteering portion, especially in the curve and build portions, to adjust the changes in desired land point that come up during the drilling process?
All right, well, thank you for the question.
I know there's a lot more to it, but I'm going to let you
so,
answer the question.
Yeah, if you remember the very first picture we shown, right, when we talked about autonomous directional drilling, the really wide picture of what we try to do. So I narrowed down the discussion to trajectory, right, which is the first step, geometrical trajectory. Now, we definitely have a plan in Schlumberger to include geosteering influx into the automation process. I would say this is going to be a last step, right? And that's definitely not my department. So I will not apologize. I won't go too far in it. The only thing I can tell you, it's part of our roadmap. It's going to be there eventually. We have the logging while drilling tools to take these measurements. Same thing as for inclination and azimuth. These measurements are made downhole, right? So if you can take the decision downhole when the measurements are made, you're going to get the maximum efficiency. I guess it's a step, it's going to come, but I guess first, at least what I'm focusing on right now is to deliver a geometrical trajectory automatically.
So is there the possibility in the future that we could just download the entire well plan to the rotary steerable tool? Because it seems like you guys are fairly close to it. You said right now that you guys are downlinking to the tool, but could you have preloaded the BHA per se, or the RSS tool or ABSS tool to be able to have the entire well plan in there? So as soon as it finishes the curve, it just keeps on going.
So if you could pull this image number 3 I sent you, maybe we can discuss that exactly. Yeah, this one.
Yeah.
So yeah, you're going somewhere there, David. You can you can take any well plan, right? However complex, and you can cut it into some finite elements which are rather simple. A straight line, a curve turn, and you understand already now, right, that we have the autonomous control systems down there now that can actually deliver each of these finite elements on their own almost. Yeah. So ultimately, yes, we do have a vision to bring the trajectory downhole completely, but I guess a much more realistic step will be to have a coupling of a surface control and a downhole control. You're going to have an automated surface control, a surface engine that will know the depth, right, very precisely, that will know the plan. And this thing will do two things, right? It will trigger the changes of autonomous downhole control systems when it needs to happen. So basically, it will send a downlink from the surface automatically and say, hey, you're vertical now, drill vertical until next time I tell you. And the surface will control that the tool actually does it. If nothing wrong happens, no downlink being sent. Surface will know, okay, I'm getting at this depth now because we measure the depth of the surface, right? So the surface automated control system will know, okay, I'm getting to the kickoff point now. So it's going to send one downlink, maybe a little bit in advance, right? So we start the kickoff right at a time. And downlink will say, now start auto curve on that tool face and that dogleg. And the tool downhole will execute. So yes, there probably will be a day where the tool, you will be able to download trajectory in the tool, but then you're going to have to feed back the tool downhole with depth, right? Until that happens, very realistically, very soon from now, we are millimeters from it. You're going to have a surface automated software that will trigger the downhole, the autonomous downhole control systems to switch from one mode to another. And that's going to be super efficient already, I believe.
Wow. This is very exciting stuff for our industry. And I know that you've got to be pretty excited to be talking about this publicly to everybody. I'm eager to learn more about the genesis of this project and what truly motivated y'all kicking this off.
So it's really everything revolves around trying to bring as much intelligence downhole and to try to get the automation process as efficient as possible. And so we always had this drive, right? So number one, right, to place our sensors, inclination, so 3 inclinometers, 3 magnetometers, sometime more. But number one, to place physically in the hardware of our tools, to place these sensors as close as possible to the bit with the challenges that contains. So that was the first. We've been doing these efforts, for 20 years since we're developing rotary steerable systems, and the push the bit, the point the bit in the brand new at bit steerable systems. All our sensors are within 6-7 feet from the bit. that was number one. But number two, we always had this really, I mean, the effort we always put in the azimuth. Inclination is, well, I should not discard it completely, but inclination is rather easy compared to azimuth. So I'm focusing on azimuth, right? The effort we put in the quality of our azimuthal measurements since the beginning is really yielding today in the capability we have to hold a line both on inclination and azimuth, and autocurve is also relying on that too, right? So the quality of the azimuthal measurements is a key part, and we've put a lot of efforts in making sure of the quality of these azimuthal measurements. And we never pushed these azimuthal measurements more, maybe in terms of challenges, is when we drill in the Permian, Delaware, right? So we drill north-south in many of these anchorage, right? So north-south is very easy for the magnetometers. And then you put on the top of it shock and vibration. So the sensors are going through hell, and this is affecting their quality. So being able to pull good azimuth measurements in these conditions is really an effort that has been going on for a long time. And yeah, so technically this is what we've been trying to do since the beginning. And the final point is, the CPU, right? Getting a tool that has a fast reaction control. It's one thing, to tell a tool now change your tool face and strength of steering. You have to do it quick also, right? So all of this is in the balance, and all of this is some progressing work we've been doing for the past 18 years.
So I got another question for you. So because of this long feedback loop time, would it be beneficial then, because I know that Schlumberger has some high-speed telemetry tools, if we could get this to be able to be, high-speed telemetry in both directions, so like high-speed bi-directional communication, would that help in this process as well?
Absolutely. I mean, so maybe you're thinking wire drill pipe, right? So this would be the ultimate bi-directional.
I'm not saying, power pulse telescope, or a power pulse at surface or something that's able to send, or telescope that's at surface that sends it the other direction.
So that is to try to answer your questions. Yeah, we are working, continuously also working on accelerating the speed of the data traveling from downhole to the surface. I tease you with wire drill pipe, right? This is an extreme one, but there is many others in between. EMAG is a very good one, by the way, right? Mud pearls, you mentioned some of the tools. We can go very far in terms of speed. We can also compress the data. But actually, even on wire drill pipe, right? The way we publish the data, the way they travel up, it's always in minutes. It's never going to be as fast as a second downhole. So no question asked, David. If you improve your telemetry, if you improve your downlink speed, you're going to get more efficient in the surface control, right? I don't deny that at all. But I will challenge this. However far you manage to get the speed of the telemetry up and down, you're never going to get to the 1 second control loop we have downhole.
That goes to show that you guys have done quite a bit on the processing power downhole. So now a lot of these, obviously Schlumberger's got a lot of tools worldwide. Is there the compatibility out there for all of your tools to be able to do this?
Yes, but we basically, our autonomous downhole control systems are available in almost all our existing commercial rotary steerable systems and at-bit steerable systems today. We have about 26,000 feet of curve drilled with that system to date, right? So we have a lot of operations, and we've done it with NeoSteer, we've done it with PowerDrive Orbit, and we've done it with PowerDrive Orbit G2, and we are working right now to implement it also in our point-to-bit system like PowerDrive XL.
Wow, that is quite the rollout. Absolutely amazing conversation. Gilles, thank you so much for all of the information and everything. Any last words for the audience and everybody out there watching?
No, thank you very much, everybody, for attending. Go visit our www.slb.com. If you liked what we talked about, there is a lot of resources we just published last week on autonomous downhole control system from Schlumberger and autonomous directional drilling. So please go ahead and visit, and you'll find plenty of resources. And my contact if you want to ask more. Thank you very much, David.
No, thank you guys for being here. It was great to be able to hear about this project, and congratulations to you and the team. All right, for everybody out there watching, if you want to be able to find out more about these SPE Tech Talks, please follow SPE on LinkedIn and all of your other social medias. And for myself and everybody else out there, as always, know your industry.